In this video, we will go over adding, subtracting, and scaling vectors. These operations are essential to many applications in a variety of fields, but thankfully are easy to learn. However, if you aren't already familiar with vectors, I recommend that you first watch the Introduction to Vectors video. One of the first logical experiments to perform with vectors is addition. Let's say we have two vectors, a and b. Graphically, one way to demonstrate vector addition is to take the starting point of b and connect it to the endpoint of a. Then you draw a line connecting the starting point of a with the endpoint of b. This hypotenuse is the sum of both vectors and is also the new vector a plus b. In addition to this graphical calculation, we can sum vectors numerically using the numerical form. For this, you add one vector to the other component-wise and place the sums in a new vector. Indeed, this vector is identical to that found graphically. Vector addition can easily pop up in your everyday life. Let's say you have a toy plane flying at a constant speed directly horizontal to the ground. This is one vector. All of a sudden, a draft of air pushes the plane up vertically. This is another vector. The vector that reflects the plane's final velocity is the addition of the first flight path vector plus the second air draft vector. The next manipulation we will address is stretching and shrinking vectors. For example, let's take x and try to make it half the length. To do this, we use scalar multiplication. For scalar multiplication, you take a constant, which in the case of vectors we normally call lambda, and multiply it by each value in the vector. So if lambda equals 1/2, we have 1/2 times x. We can also do 2 times x, or -1 times x. As you can see by the changes to x, multiplying a vector by a constant lambda stretched and shrank the vector. Note that scalar multiplication, which is multiplying a vector by a constant, is different from multiplying a vector by a vector. These types of functions include the dot product and cross product among others, and for these other functions please refer to other media in the Jolt. And to subtraction. Recall that subtraction is just adding the opposite, so we can fully demonstrate subtraction by using vector addition and scalar multiplication. A minus b plus a plus negative b equals a plus -1 times b. This is the numerical equivalent of flipping the direction of the vector that is to be subtracted and then adding it to the other vector. Lastly, it can be useful to know that vector addition and scalar multiplication follow the commutative and associative laws. To conclude, the best way to get comfortable with vectors is to play around with them. Don't be afraid to add, subtract, scale, and graph your own vectors. The supplemental exercises are a great place to get started.